Hello all, welcome to my channel. I'm back with another video. In this video, we will be talking about some of the common places or instances where Spark can throw error, and we will see how we can find those errors and how we can solve those errors. The solution will be in part two. In part one, we will just discuss the different types of errors that we can see while we are running a Spark job. So let's get started. So at a broad level, we can classify and Spark error into four broader categories. Uh, One is memory linked errors. So when I say memory linked errors, so these errors come due to the memory pressure that is there either on the driver or on the executor. So based on that, we have certain sets of errors that we can see. Then we have another set of errors that comes is due to shuffle. And as we know, shuffle is a process where the data from one partition or one executor is moved to another partition or another executor for doing aggregations, joins, and other stuff. So that is where shuffle is something which causes certain errors. Then we have analysis exceptions, which are, I will say generally we will not see that frequently this analysis exception unless we are doing something wrong or we are not following the best practices of writing the Spark code. If we are following that, then the analysis exception will happen very less frequently. But yes, that does come up in many of the scenarios. You might not have written that code, someone else might have written the code, and if something goes wrong, you will have to find out where it went wrong. So it is good to know. And then we have another all those errors which are not falling in either of these categories. We can put that in under one umbrella called miscellaneous errors. That comes like that. Those are majorly linked to uh, errors that happens because of some configuration error or the way we are trying to do something or uh, the process that we have taken to write something into a system. So that's where these errors comes. So let's see these details, these errors in some detail. So the errors due to memory pressure. So at the driver, we can have out of memory errors coming at driver for different reasons. One can be the driver is running out of memory. Let's say if we are doing some processing and that processing itself is taking time. Generally, there is no distributed processing happening at the driver, but we still have certain data processing, or not data processing, but I will say metadata processing that happens at a driver. For example, when we do an SDFS list, ls command or Spark listing of a directory, at that time Spark creates an in-memory file index that okay, which file maps to what ranges, and so there are some in-memory file indexes that gets created, and if that is very big or it is not able to fit in the memory that is available for this driver, so that can give you an out of memory error. So this is one place where we can we know that okay, although driver is not doing any data processing, just because it is doing some metadata operation, and if that metadata operation itself is very big, we can see this in memory file index error coming, sorry, in memory due to file in memory file index that we are creating, we can see out of memory errors. Then we will see certain errors which are, for example, memory error, sorry, not a memory error per se, but it can be a max result error. So this error happens because there is a limit of how much of data we can transmit or collect as part of our driver process. For example, let's say if we have a very big data frame which is distributed across nodes, and let's say we are collecting something out of it. Let's say we are trying to get some data out of it for any purpose, and let's say if we have collected the data and that data collection itself is very large, that again can throw an error, and you will see errors like this, that okay, total size of the serialized results of X tasks is YMB, which is bigger than the Spark driver max result size, or generally which is set to some MB values. We can do some configuration to increase it, but if we are saying these kinds of error, then there is definitely we are doing wrong. That is an anti-pattern that we should avoid. For example, if we have a requirement of collecting something large, we can write it to an SDFS location or a persistent location and then read from there. So that's how we should be doing it, not via the collect part. Then the other set of errors can happen if because of at driver end is we will see an errors like not if enough memory to build the broadcast the table. This kind of error comes, let's say, when we have a table which is small enough that can be broadcasted, but the process of broadcasting is that okay, the smaller table is first sent to the driver then creates an hash table, or driver broadcasts it to the other all the other executors which are there uh, for join or whatever purposes we need that broadcast table as. So in that case, what happens that whenever we are saying that the smaller table needs to be broadcast, it needs to fit both as in the driver as well as in executor processes. So generally what happens in Spark pipelines, what we will say is we will have a smaller driver and we will have bigger executor. So that there will be no executor side error because of the broadcast value or the data that is being broadcasted is small enough to fit in the executor memory, but it might not fit in the driver memory. And hence, we will see this too big broadcast error that might come in the driver side. Then we have container out of memory errors. This is for specifically for uh, Kubernetes, but it can also be for Yarn. What happens is if we have a lot of memory overhead and we have plenty of non-Java objects, like if we are working with Python, so those non-JVM objects require will incur the memory pressure, and that gives us an Spark driver dot memory overhead errors that can come. So this is another place for which a driver can go wrong or driver can throw an error. Then let's go to executors. So executors have there are different reasons why an executor can throw an error. One can be out of memory error. So if the data that is being processed for that particular partition or an executor is exceeding the limit that is there, then it will throw an out of memory error. So it will say executor lost failure, saying that okay, number of is this amount of GB of total physical memory that was used was going above the limit that was set. So that kind of error can come. Then we have out of disk error. So what happens is let's say if we are working in a distributed environment, each of the nodes had some disk attached to it, and that disk is used for, let's say, temporary data. And let's say, for example, shuffle data gets stored in the local disk directory as well. And while working with Kubernetes environment, and at that time, what it may happen that if we are running out of disk space, we might see an error saying that okay, no space left on a device. So that kind of error we can also see. Then we have this is something similar can happen when we are doing persist or a cache operation where we are using local directory as a method of storing the data. So that is also somewhere we can see this out of disk error coming. Another kind of error can happen if we have a too large record. So this happens when we are doing an explode or whole text as file, whole text files kind of an operation. So this, or let's say we have a nested JSON data. So when we are doing the flattening, we might see this kind of error. So this also can come from UDF. So let's say if in the UDF we are doing some batch operation and that is doing some explode, let's say from row to column or column to rows, that time also we can see this kind of error which says input is too large to fit in a byte array. So that kind of error, which is nothing but a too large record array error. Then we have container out of memory. This is similar to what we have seen in driver. So if we are processing more data than the limit set by the executor memory, we will see out of memory error, and we will see exit code 137, which is generic Kubernetes code for out of memory errors. Then we have executor container killed by yarn for exceeding memory limits. This is something similar to what we see in case this happens for this is specific for yarn, but this is where we will see an error log message which says container killed by yarn for exceeding memory limits, and it says that okay, this much amount was physical memory was allocated and you have used more than that. So that this is something again something similar to what driver memory head was doing. Something similar can happen at executor level as well, and then we will see an executor memory overhead error. Then we can have errors linked to GC overhead. This means that this error happens. This is a JVM concept which says that okay, any Java process which spends more than 98% of time doing garbage collection and only 2% or less than 2% of heap space is getting recovered in every execution, we will see GC overhead limit exceeded error. And that means that what is happening in this case is that the rate at which the GC is getting cleaned up, it is being filled up with a higher rate, and hence we will never be able to clean those objects, and hence we will see a failure. So GC overhead limit exceeded is something which again comes very frequently. Uh, and also it can also say that okay, instead of printing GC overhead limit, it can print GC instead of saying that, it can simply say Java lang out of memory and Java heap space is running out of limits or out of ability. So that is something, some other error which also can appear. So there are this out of memory errors are of four type, like exceeding physical memory, exceeding virtual memory, exceeding executor memory, and exceeding the heap space. So these are four out of memory errors that we can see there. Then we have errors due to shuffle. As I was mentioning earlier, shuffle is a process where the data is moved from one executor to another or one task to another task for the purposes of doing reducing or doing a group by operation or doing a joins so that the same keys are present on the same executor. So that time shuffle, if during the shuffle, if the node which is responsible for the shuffle data goes off or goes down for some reason, we will see fail to connect to IP, and IP address will be of the executor, and we will see this error that okay, fetch failed exception came. Then it can also happen that the metadata fetch fail exception can also be seen. This is where when the executor is not able to connect with the shuffle service. Let's say if we are using external shuffle service, and if the executor is not able to touch or connect with the shuffle service, then it will say that okay, missing an output location for the shuffle, or it will say metadata fetch fail exception. So that is another place where another type of error that we can see due to shuffle. Then we have network timeout. So again, this is because we are doing lot of let's say if we are doing a huge shuffle, and then so let's say if you are working on a cloud environment, each of the EC2 comes with a certain bandwidth, network bandwidth that it is available for them. For example, large bigger instances have 10 Gbps connection between them. So if we are doing so much of shuffle that capacity getting exhausted, or it is not able to cope up with the requirement that we have to try to do the data transfer, we will see a network timeout happening, that okay, in the given time we are not able to do that data exchange, and hence we will see a lot of network timeout errors in those cases. Then we have shuffle block manager greater than 2 GB. So this is again which is something that when we do a shuffle, the block size should be less than 2 GB. That's the limit that is said, and it happens because of two reasons. One is either we have very small partitions or we have skewed partitions. In that case, we can see we might see this type of error. Another error that might come is because of sort merge join can result in an OOM if the rows are very large. So that also is a place where we can see an error. Shuffle may also trigger an out of memory error, because while doing the shuffle, if we have not set the memory fraction to the reasonable limits, we might see OM error, which might not be the actual OM error. It might be due to a shuffle operation that is causing that, and it is in cascading effect. So that is again one thing that we have to note. So again, for the shuffles, we have fetch failed exception, fail to connect, and fail to fetch kind of errors. Then comes the error due to a SQL analysis. So this is, as we know, when we write a program or a Spark program, it goes through different phases, and one of the phases where it does the SQL analysis to find out the logical relations that is there, maps to the right objects which are present in the catalog. So that analysis phase is where we will be seeing any errors which is linked to the SQL analysis. So there is a class in Spark code base which is called Apache.Spark.SQL analysis exception, and in that there are different exceptions that are mentioned. One exception can be is, let's say, if you are trying to modify the Spark configuration which is not modifiable. Like for example, let's say when you are running in cluster mode, and then if you have said you are trying to increase the driver memory after the Spark application has already come up in the cluster mode, so that is not something which is applicable, and you will see exception. The exception might also come, let's say the catalog that you are using does not have the table or the view that you have mentioned. Let's say if you have some spelling error or some typing error which caused the table to be not present, so that kind of error will give an analysis exception. There are others like path does already exist or undefined function, database not found, path does not exist, unable to infer the schema, unable to insert into. These all are certain sets, certain error types that you will see which are linked to analysis exception. And to fix that is to fix your code. So that's the solution that you have to implement. Then we have PySpark errors, which is specific to PySpark, not generic Spark. So for example, Py4j Java error. This error can happen when uh, we have invalid data or insufficient memory or incorrect configuration settings that we have done, or we have missing jars. So that time we might get a py4j java error that is there. And this also can come, this error might be subclassed into class not found exception or null pointer exception. Sometimes you will see sql exception that will be coming. So all these are part of this bigger umbrella term that we are using, but again, these are different types of errors that can come while you are working with PySpark. There can be an error linked to pickling. Pickling is a process in Python which is something similar to what serialization does. It's not similar. It is actually a serialization process. And if we are not able to serialize that particular object, we will see this pickling error that comes. So that is another kind of error that we will see in uh, PySpark. For example, there can be analysis exception which can be part of, let's say if we say a column, a variable, and that variable is not initialized correctly, and if we use that variable in, let's say, some expression, that time we will see analysis exception saying that we cannot resolve this particular column name that we are seeing. So that is something which can come. We can have value error, like for example, sampling ratio is one um, way which we do a data type identification. And if the types cannot be determined by the first 100 rows correctly, then when the data comes of that type which is not compatible with the type that we have given, that time we might have an value error. So it's better to solve this. We have to just specify the schema ourselves rather than relying on that sampling ratio that Spark does to infer the schema. Then we can have serialization errors. As we know, every function, task, and the things that needs to be sent across different executors have to be serialized. And if that class is not serializable or result is not serializable, then we will see serialization errors. And those errors can be of different type, like not serializable exception, task not serializable, class not found exception, or unsupported operand exception. So that those kind of errors that we can see due to serialization. And let's say you are using a custom class, then your classes should extend the serializable class so that it can be sent across. So this is another area where we can see a lot of errors coming. uh, we can have stage failures task, like this is in cascading. For example, if a stage task fails, so we will see cascading effects. Like first it will say that okay, some of the stage failed, then if you go and find out the task, it will say that task failed, and then it will actually say the task failure region. For example, let's say if the serialized result of an task is let's say bigger than the driver.max result size, then again also we can see then something similar error that can happen. There are some other errors as well. For example, this course gain scheduler error is mainly encountered when there is a failure of the driver. Although the logs will say course gain scheduler executor backend was not able to find the course gain scheduler, this simply means that your driver is gone. So find out why driver went away. This logs you will see in the executor, but it will be something which is linked to a Spark driver going out, maybe because of out of memory or some other process has killed it. Then we have some other miscellaneous errors that we that can happen is like you will see notice things like an error occurred while calling an object dot method. This happens because again, let's say if you are working with Python and that Python class is not properly initialized, or that object that we are trying is does not have the particular method. If we try to make a call, it will say that okay, it's not able to call that. We can have errors leading to high metadata exception. We can have missing files, file already exists, or class not found exceptions. A file already exists is something which is not, which is again something. But I will like to say it as an ambiguous, because it's not the actual error. This error is somewhere else. This error comes up. For example, if we are doing in an insert overwrite in a high meta store managed table externally using Spark. So what might happen is that let's say the previous run had a partial write, then it will say file already exists exception. And then we'll have to just do a cleanup and then we rewrite that will work. So that kind of errors also there, and like there are other sets of errors, for example, class not found. This is something if we are working with some external integrations and those binaries are not by default available in Spark distribution, we have to put that. And if we don't put that in the right location where the jars should be placed, if we don't load them in the right class path, we might see class not found exception. So the approach to solve them is to put the jars in the right place, load the class passes as well. We can say extra class path for driver as well as for executor. Uh, how we can handle these PySpark exceptions is like we have first have to understand what is the error, from where it came, and what kind of error it was. For example, whether it was an analysis exception or it was an exception from Py4j Java error. So, for example, let's say if we have handling here means not solving the problem, but handling in code makes, for example, if we know that this might come an error as an exception, how to catch that and do some action based on that. So for example, if we have this analysis exception or Py4j exception, so we can import those classes which are present in Py4j protocol and Py4 SQL utils, PySpark SQL utils, and then based on that we can take a call. So we can also do um, multiple level. So for example, we first catch Py4j Java error. If that is not there, we call analysis exception error, and so on. And then we can decide whether to fail the task, whether to log something, or do take action, do a cleanup, and then proceed ahead. And same thing is available in Scala API as well, so that we can have Spark exception class, which has everything, all the exceptions, and we can do try catch based on a case matching, and then we take specific action based on the what type of error that has happened. So this was it for this video. We have gone through some of the common errors, why those errors are very interesting to or hard to find. The reason of that being is Spark does lazy evaluation, and sometimes might not see the error immediately. We might see error when the whole code runs. So it is good to know what particular error means, and where it is coming from. So that was it for this video. If you like it, do share and support this channel. Have a nice day. Thank you.